Hola a todos. Desafortunadamente, mi español no es suficiente bueno para hacer esa charla completamente en español. Pero mi Kotlin es mejor. Entonces, Kotlin. So, Kotlin in general promises a lot of good things. Promises a safer code, promises less boilerplate code. So, when I started using Kotlin and I started looking at some of the Kotlin libraries around there, I saw things like this. This actually is part of the core KTX, one of the Android libraries. So I see keywords like this, like inline. Then in other samples, I see stuff like this with other keywords, like sealed. So I started wondering, okay, what's up with these keywords? Should I use them? And I wanted to understand, like, what's the magic, actually? What does Kotlin do with these keywords that makes things better? So what I want to do today is to ruin that Kotlin magic for you. I'm sorry. So in this talk, we're not going to look at the bytecode, because I like you guys. But we're going to look at decompiled Java code. And at one point in the talk, there's going to be a quiz. And you better answer, and you better know the right answer. So let's get started. So how many people here are Android developers? OK. So for the people that are not Android developers, I will use a few examples that are related to Android, but I'm sure you'll be able to find analogies with whatever you're doing. So let's say that we need to display a list of users. So to represent a user, we have a data class that has a name and a Boolean that says whether the user is active or not. So if the user is not active, we just want to show it like that grayed out. So because we also want to be able to tap on a user and do something on the tab, like activate it or deactivate it, we're defining an on-click listener that gets a user. Okay. We also want to provide, like, instead of just providing a list of users, we want to provide to the UI a list of user UI models that has the user, but also that on-click listener. So wherever we're creating this model, we can also handle what happens when we're clicking on the user. So this means that we have to create a user UI model with the user, but also all of this like object on-click listener, where we're implementing this on-click listener, and I already got tired just explaining how much code we need to write. So luckily, Kotlin supports functions as a first-class citizen. So this means that instead of implementing our listener, we can just pass a function to our data class. So we're just passing that click action that gets the user as a parameter. And then when we're constructing the user UI model, we can just pass the action as a lambda. So we said that we also need to handle the user click. So our method that handles the user click would look something like this. Would get the user, would get the action, and in case the user is active, we would trigger that action based on the user. So what we see here is that we have a function that gets another function as a parameter. So in general, functions that get other functions as parameters or return other functions are called high-order functions. OK, so we have our handle user click. Now we have to use it. So we would call something like a bind user method, where we're setting the text that needs to be displayed. But on the text view, we're also setting that on-click listener. So here, we're just calling handle user click of the user UI model and the click action. OK, so now it's the time when we're looking at the decompiled Java code. So I was curious, OK, what happens here? What happens when we're calling this function? So this is what the compiler is doing. So it creates our bind user function. It's creating this new on-click listener, where it's just calling the function that we defined above. That's all. OK. But what if we change things? What if we decide that instead of handling or defining the action in the place where we're creating the user UI model, what if we want to call or define the action here in the bind user? So we're defining the action directly here. What's the difference? So in the decompile code, we see something like this. We see a function1 null.instance. That doesn't tell you much, but actually what happens here is Kotlin, the Kotlin compiler, creates a new function object for every lambda that needs to be passed. Okay, so this means that if we would call this handle user click in a ton of places, let's say that it would be a utility method that we would end up using a lot, we would create that new function object again and again and again. Unnecessary? Unnecessary if we use the inline function, inline keyword. So what happens here? With by putting inline instead in front of a function name, our code changes, or our decompile code changes. So here we can see that instead of having that function call that we have before, where we're creating a new function object, this time the contents of our handle user click method is just copied inside our own click listener implementation. So this means that, yeah, so here we can see that only the isActive part, or is called the same as it will be for handle user click. So this means that by using inline functions, we're avoiding these extra classes or objects to be created. Okay, but what if our code changes? What if in our handle user click, we want to do something with that action? Let's say that we want to, I don't know, keep it inside a variable and do something more with it. Well, in this case, the compiler complains because you can use inline functions when you're calling or passing functions to other inline functions. But you can't use inline functions when you want to store them. So to do this, you will need to use the no inline keyword. So why is this? Why can't we store this? So because the compiler just copies that code, it means that, okay, it wouldn't know a reference to what? How should it hold a reference to that code that's copied? It's no longer an object there. I hope you paid attention. So let's see what happens in some cases. Okay, so we said that we have our inline handle user click function. So let's say that in our bind user, we're directly calling handle user click, and we put a return there. What happens with this return? Where will it return? What do you think? Will it return to handle user click? Will it return to bind user? Bind user, okay. Other options? Will it have a compile error? So if we use handle at return at handle user click, indeed it will just return outside the handle user click, and whatever happens in the bind user will be called. But by just using return, I don't know who said bind user, but yay, 5 points for you. Okay, what if we do this? What if we have a set on click listener, and inside the on click listener, we're calling handle user click? What happens here? Okay, other options? Don't be shy. I didn't know Argentinians are shy. Okay. So in this case, we actually get a compile error because it's saying that return is not allowed here. So, but rather instead, our possible options are either return at handle user click or return at set on click listener. So why is this? I said that the main difference here is that we have that text view set on click listener. So if you look at the decompiled Java code, we see that, okay, a new on-click listener is created, and then the code gets copied. So we couldn't return to the bind method because we're inside a class. We're inside a class definition, so the compiler can't know how to get out of that class completely. That's why the only possible options are return at handle user click or return at set on click listener. Okay, so this means that with inline functions, we get rid of these new function instance creation. The code is moved all around, so we should just inline all the things. Should we just inline all the things? So I would say yes, if you have functions that take a lambda as an argument. But no, otherwise. Otherwise, you just have a low performance impact. And even more, the compiler will tell you this. If you just have, for example, a handle user click that just gets a user, and you try to put inline in front of it, the compiler will tell you that, hey, actually, inline works best for functions with parameters of functional types. So you're not really gaining anything. But you should also use inline functions for functions that take a lambda as an argument and are small. So keep in mind that you're moving code from one place to another, not moving, you're copying code. So this means that if you have a bigger object, or a bigger method that does a lot of things, that ends up being copy-pasted from one place to another. Even more, if you look at some of the functions defined in the Kotlin standard library, you'll notice that a lot of the functions that are inline are one-liner pretty much. They're always very, very short. Okay, so we said that functions that take other functions as parameters or return a function are called high-order functions. And then we looked at inline and how it allows you to get rid of that extra new function objects being created. And in the case where we want to store a reference to that function, we should use no inline. Okay, if you didn't have had enough of the word inline, we're going to talk more about inline, but this time about inline classes. So a word of warning, inline classes are experimental. So this means that what I'm telling you now might change tomorrow or whenever a new version of the inline classes is released. Okay. So in one of the projects that I was working on, we had something like this. So we had a comments, we had a story to which we can add comments. But we could also add comments as replies to those comments. So our functions actually look pretty similar. We could post a comment to a story by passing a body, story ID, and user ID, so string, long, long. And to post a reply to a comment, we would again have a string and long, long. Both methods return as a result of comment response. So this means that it was quite easy by mistake to just call a function with the wrong parameter, call, I don't know, post story comment, and instead of passing the story ID, just pass the comment ID, just because the types didn't help. So we wanted to avoid this. We wanted to have the compiler telling us or enforcing these constraints. We wanted to have these strongly typed. So have something like a story ID that is a story ID object. So we can't rely on just human mind or human error to avoid these kind of things. So one way to do this would be to create a data class that just wraps the story ID. I know that actually in Java, this is quite a common thing to do, especially for backend developers. So yeah, we could do this. But the problem with this is that every time we actually end up using the story ID, we end up we have that extra object initialization just because we want to wrap it. So it's a good practice, but creates that extra object creation. So this is why inline classes were created in Kotlin, to avoid that extra object creation. So let's see what's up with inline classes. So again, the role of inline classes is just to wrap an object. And actually, this is the part where I started liking Kotlin more and more, because Kotlin enforces this best practice. So it's like, you're saying that all you want is to wrap an object, okay, then I'm going to force you to only do that. Because inline classes have a series of limitations, like they can't take more than one parameter. They are not allowed to have any backing fields. They can't have init blocks. They can't extend classes, but they can inherit from interfaces. So for example, I can have an interface ID and have my inline class story ID inherit from it. And also, it can have properties and functions. Okay. So let's see what happens with inline classes and why are they useful, or when, and what's up with them. So we said that we have an interface ID and an inline class that just wraps an ID. What's the magic there? If you look at the decompile code, we see that the story ID is just a final class that implements ID, that gets a long ID as a parameter and as a member, and then has a getter for it. Okay, that's nothing much. But what it also has is providing a boxed implementation of it. So this means that in some cases, Kotlin is going to use this as an object instead of a wrapper. So more precisely, an inline class is represented as a wrapper or as an underlying type, depending on the situation. So an inline class is going to be boxed when it's used as another type. Keep this in mind for later. You'll need it. OK, so what does that mean? So let's say that we have a function that's called do stuff of a story ID. So this means that in the decompile code, this is going to be unboxed because it can just pass the long. It knows that, OK, I don't need an object. I can just pass it like this. But if, for example, I have a getID where I'm returning the ID, this means that this is an object. So this will be represented as boxed. So it's going to create that extra object for us. Second quiz. OK, so let's see what happens in some cases. So let's say that we've defined a S1 of a story ID. What happens when we want to pass this inline class object inside of a list? Is it going to be auto-boxed or not? Who thinks it's going to be auto-boxed? So used as an object. OK, so everyone thinks that this is going to be used as a primitive, as a long? Do you want to know the answer? Do you want to guess the answer? Boxed? It is boxed. Because collections or arrays expect objects. So this means that it will use the story ID object. OK. Next one. Let's say that we pass a nullable story ID. Auto-boxed? OK, I hear some yeses. Yes, because it's nullable. So it will be treated as an object. OK. Last one. Any. Auto-boxed? So it's going to be used as a primitive? So any is an object. So this means that it will use the boxed implementation for it. So in general, the rule is that auto-boxing is happening for nullable objects, inside collections or arrays, or when objects or any are expected. OK, we're not done. Let's look at equality. Let's see first what happens if we have S1 equals S2. Primitive. Both of them? Unfortunately not. So if you look at how Kotlin implements equality, we see that it expects objects. So because it expects objects, it means that new objects will be created. OK, S1 equals S2. Wait, say that again. Okay, what's going to be auto-boxed? S1, S2, or both? So, inline classes implement equals differently. So with inline classes, because we're calling equals on S1, it already knows that S1, it knows the type of S1. It doesn't need to create an object on it. But the equals expects an object. So this means that S1 will be used as the underlying type, whereas only S2 will be boxed. So this means that in general, when you're using inline classes, indeed they do provide this like benefit when they're used as an underlying type, but we do have these kind of downsides that are sometimes hidden, I would say. Like, I was quite surprised when I played around and found out that this works like this. Okay, so when I showed you the do stuff methods, I didn't really cover this part. So you see that it's not, the decompile code isn't just do stuff, it adds these extra characters. So these extra characters are called mangling. And Kotlin does this because it wants to allow developers to pass or to create functions, overloaded functions. So you're able to have do stuff of a story ID object, but also of a long. That long can be a story ID, but imagine that in the same class you want to have a function with the same name, but with something else, maybe not story ID, maybe a comment ID or user ID. So then that long can be a valid thing. So this is why the compiler allows the creation of both types of classes. But the disadvantage of this is that this mangling isn't recognized from Java. So if you're in the process of migrating your code from Java to Kotlin, you can't use inline classes that are being used in the Java code because it just won't compile. Okay, so inline classes. They're great because they provide this idea of just being a wrapper. They provide this strongly typed functionality that we need. And Kotlin allows to do this by providing a series of limitations. We can't have more than one parameter. We can't have backing fields, init blocks. We can't extend classes. And unfortunately, we can't call these from Java. But also, they're quite flexible because they can inherit from interfaces and can have properties and functions. So I think what we need to remember also is that while in some cases they will be used as an underlying type, so they will serve the function that we really hope to have, in other cases, they will not. So this means that in some cases they will have the same, let's say, performance as they would have if you'd use a data class. Okay. Next topic, sealed classes. So let's say that, so sealed classes are used for representing restricted class hierarchies. So when a value can only have a specific value from a limited set. So practically, a short way of seeing this is like an abstract class where you can only define the implementations inside the same file, and that's all. They can either be represented as nested classes or outside the class, but they just need to be inside the same file. And what's great is that you can use them something like this. So you can, chances are when you get an object like this, you want to be able to treat all cases. So you want to check, okay, if result is success, then you would want to do something. When result is error, you want to do something else. But what if you want to make sure that when you're using the result, you're really treating all cases? What if you want to make sure that, I don't know, if you're by mistake commenting out one branch, that this ends up becoming an error? Or what if, I don't know, someone else ends up adding another branch or another, I don't know, let's say an in progress to a result, and then you forget to check all of the places where your result is being passed or where your result is being used. For those kind of cases, you would have to rely on your memory or on your search skills, but rather, I think it's better if you rely on the compiler. and we have this enforced by the compiler. So what I would want to have is an error when I forget to implement something, and the compiler to tell me this, and to tell me what branch I should implement. So this only happens when is treated as an expression. So to treat it as an expression, I created an extension property to it. I created a .exhaustive. And this is actually just an extension property on T, and that's it. So actually when becomes exhaustive when it's treated as an expression. It would also be treated as an expression if you would do something like return when blah, blah, blah. So you would still get that same compile error. But if you only have what we have here, like when do something without that return, then it wouldn't be an expression. So CL classes seemed magic. The compiler just somehow knows and enforces these things. So I wanted to look at this more. So CL classes, I said that they don't have to be nested. They can be declared inside the same file. And they can be any type. They can be a data class. They can be just a class or an object. So actually, a CL class, as I said, it's an abstract class. But the difference is that it creates that synthetic method that gets a constructor that gets this default constructor marker. So in case you're wondering what's up with this class, with this default constructor marker, because you probably never used it, that's because you can't use it. This is something that only the Kotlin compiler uses. And then if we look at the implementations, so for example, for state 1, we would just have the data being passed. And then in the implementation of the class, in the decompiled Java code, we see that the compiler knows that it should call this the super using this default constructor marker. If you would try to create this class outside this file, then the compiler wouldn't know about this constructor, and it wouldn't know what to do there. Okay, so if what if we connect what I said about CL classes and about when? How does the bytecode look like? So we have a state, and then the when is just converted in a if-else, if-else, if-else branch, where the last if would throw a no branch matched exception in case no branch is matched. That's just the typical when implementation in these cases. But then I was curious to see, okay, what's up with .exhaustive? Why, by just creating this extension property and treating when as an expression works? What's the magic there? So actually what Kotlin does here is create just a unit, and then it instantiates this unit on every if branch. And then at the end, it just calls get exhaustive on my unit. That's it. But actually, if you implement something like this yourself, so if you have a variable that you would declare before an if-else, you would get the same compile error in case you're forgetting to add something. The compiler will just tell you that, hey, you actually didn't instantiate this. So the Kotlin compiler just does the same thing that you would get otherwise. Okay, that was it with CL classes. Now let's look at collections and sequences. So I was saying that in one of our sample apps, we had something like this. So we had a story that could get comments, and then you could either add comments to the story or add comment to a reply, or you could even add a reply to another reply. So let me show the API. So in the API, we would get we would be able to get comments based on a list of IDs. And we would get back a list of comment responses. And the list of the comment responses had links to those kind of useful links, including other comments. So these would be IDs of the replies to the comment. So this means that when I wanted to construct my UI, I had to create the first, to get the first level of comments, then get the replies to those comments, then get all the replies for those replies, and so on. And then we had to match them because we had to show them in a nice UI. So in the end, we had to work a lot with lists. But luckily, the Kotlin standard library provides a set of extension functions with on lists, things like group by on map or map. So that meant that I didn't have to reinvent the wheel and re-implement all of these grouping of comments and so on, but rather I could just rely on things that were already implemented for me. So we talked about collections, and collections work eagerly. But Kotlin has another, let's say, way of working with lists, and this is like as sequences. So sequences are like lazy lists. I know eager and lazy might not be much or might not mean much, so I thought it would be interesting to go over an example and see what's the difference between them. So let's say that we have a list of objects of different shapes. In the first step, what we want to do is just to make a shape yellow, and then we want to get the first shape that is square. I know it's a simplistic example, but bear with me. So, in the collections, map is triggered. When map is called, then the entire collection is copied, and the color is applied on it. And then, when first is called, it's going to take the first element of the collection. We'll check, is this a square? It's not. It goes to the next one. Is this a square? Yes, we're done. But with the sequences, it's no longer like this. It just goes over map, and only when first is called, only then map will be triggered. And only here, and here, instead of working on the entire collection, we will work on each element of the collection. So first, the circle will be retrieved, will be made yellow. Then it's checking, hey, is this a square? It's not. Then the next shape is taken, it's made yellow because map is called. Is this the square we're looking for? Yes. And this is where everything ends. So this means that with sequences, elements are evaluated one by one. So those elements at the end, we didn't even get to them. So we were able to save that extra memory, extra performance. Whereas with collections, each operation is executed on the entire collection, and then a new collection is created. So this means that if you have a big array with maybe a lot of operators here, so like, I don't know, some map and flat map and whatever, then a new collection is created every time for every operation. So what's the secret? What's the difference between collections and sequences? So sequences actually, instead of holding a reference to the entire collection, they just hold a reference to the iterator, that's all. They don't operate on the entire object. And then methods like first, operations like first, are called terminal, because only when sequences get to that kind of terminal operations, only then the intermediate operations are going to be triggered. So if you're wondering which operations are terminal, which ones are intermediate, usually the description, the Java doc for it will say that, hey, this is a terminal operation or this is an intermediate operation. Okay, let's look at the decompiled Java code. So we see that for map, we are passing a lambda, and then that lambda is afterwards used to transform a sequence. Actually, what's happening inside the transforming sequence is the transformation is stored, and only when we get to a terminal operation, then each transformation that's a parameter of the transforming sequence object is being called. Whereas when we're talking about collections, we have a map of a transformation, but here, instead of storing it, we're just creating a new array list where this transformation is applied directly. So one interesting thing to look at is the fact that collection operations are actually inline functions, because on collections, we're just applying directly that transformation. Whereas for sequences, we're storing that transformation. And as we said at the beginning of the talk, because we want to store the transformation, it means that we can't use an inline function. We would have to maybe mark this action as no inline, but then there's no point of using an inline function when we only have an action that's no inline. Okay, so you would wonder, what should you use? So I would say, as a rule of thumb, if you have a large number of elements, then you could use sequences. If not, you could use collections. In reality, the answer is that it actually depends on what you're using, so, and how you're using these collections. It depends on whether you have an object that's quite big. It depends on whether you have a lot of operations, because in the end, with sequences, you are still storing some objects. You're storing these transformation lambdas. So it still pays a cost. But independent on which one you use, definitely check out the extension functions on both collections and sequences, and make sure that you're not reinventing the wheel. So we looked over high-order functions, we looked over inline, we looked over sealed, and we learned about sequences. And that's all I had for you. And now actually it's your turn to ask me questions. Thank you. So, can I still have the mic? This one isn't working, I think.
Quick question. We've been working with Kotlin on the project I'm working on for a long time now, and I've seen come and go a keyword that's called cross-inline, kind-ish. What's that do without the...
So I asked myself the same question when I was researching for this talk, and I couldn't get it. So I even ended up asking some folks from JetBrains, like, okay, when should I actually use cross-inline? Is there a rule? And it felt like the conclusion is whenever the compiler tells you to add cross-inline, add cross-inline. So sorry, I really tried to find the answer for this as well.
You knew someone would ask that.
Yeah. Well, you can too on the JetBrains Slack.
Okay.
¿Alguien más? Allá. Vamos para allá. Manteme la mano arriba, así te veo.
Hi, great presentation, by the way.
Thank you.
About seed classes, is there any difference between using instantiating them inside the seed class, the parent class, or like at the same level? Or is there any use case that you should use one or the other?
I don't think so, or not that I could find. I know that the possibility of declaring them outside the nested, outside the class, was added in a version after it was added, so it felt like this is just something that developers wanted, and I actually haven't checked if there's a difference in the bytecode that's generated, but I expect it's not. But what you could do is check it out and then let me know.
Okay, thanks.
Thank you. I'll be here anyway the rest of the day, and feel free to grab me. And the thing is that I know it sounds like I came here just to tell you things, but I actually came here because I want to hear from you. So I want to hear what kind of problems you have with Android, because I want to make Android better for you. I want to pass your problems forward to the engineering teams and hope that we get Android better for everyone. So thank you for having me.